18 days ago, at 10 minutes past 3 in the afternoon, the ground 11 kilometers north of Redwood Valley, California, snapped, and a magnitude 5.6 earthquake rolled across Mendocino County, the strongest onshore shaking that corner of the state had felt in years. In the 18 days since, the instruments have recorded 211 aftershocks in the zone around that rupture. More than 5,300 people filed shaking reports with the United States Geological Survey. The maximum measured intensity near the epicenter reached level 7 on the intensity scale, the level where furniture moves, plaster cracks, and unreinforced walls begin to fail. The Federal Impact System flagged the event at alert level yellow, meaning localized damage was expected, and the Shake Alert early warning system fired, pushing warnings to phones ahead of the strongest shaking. In this past week, while the aftershock zone itself has been quieting down almost exactly on schedule, the wider sequence did something that earned it a second episode on this channel. It moved. A magnitude 3.9 to the northeast near Alder Springs. Then, days later, a magnitude 3.8 and a magnitude 4.4, 3 hours apart, beneath the valley north of Cavallo, 30 miles up the same fault corridor from where this all began. In our last episode on this sequence, I told you that after every significant earthquake, government scientists publish a real numerical aftershock forecast, updated continuously, available to anyone. Tonight, we are going to do something no headline will do for you. We are going to open the actual forecast for this actual sequence, the one generated this very week, and read it together, line by line, number by number, the 1 day window, the 1 week, the 1 month, the 1 year, what each probability means, where the numbers come from, what they cannot tell you, and what the scientists watching this corridor are looking for next. No guessing, no dramatizing, just the facts, the science, and the real stakes. A quick word first. If you are in Mendocino, Lake, Humboldt, or Trinity counties and you felt the main shock, the Cavallo pair, or anything in between, tell me in the comments where you were and what it felt like. Those 5,300 official reports began as exactly that kind of account, and the ones under the last episode were genuinely valuable. If you have not seen that previous episode, where we mapped this region's twin sequences, the offshore Petrolia cluster and this inland corridor, and told the story of the Macama Fault, the Hayward system's forgotten northern sibling, it is the essential first half of tonight, and everything here builds on it. And if you want the next update on this sequence when the picture changes, subscribing is how you get it. Now, to the data. Start with what 18 days of instruments have taught us about the main shock itself, because the picture has sharpened considerably since the first hours. The June 24th earthquake struck shallow under 9 kilometers deep in the heart of the Macama Fault corridor. And shallow is why it hit the way it did. Those 5,300 felt reports came in from across Northern California, from the coast to the Central Valley, but the reports that matter most cluster near the epicenter, in Redwood Valley, Potter Valley, Willits, and Ukiah, where community intensities reached the high 6s and the instrumental maps peaked at intensity 7. On the intensity ladder we decoded in our Japan episode, 7 is the level engineers call very strong, difficult to stand through, unsecured objects thrown, damage beginning in vulnerable buildings, and the reports from the area matched, items off shelves, cracked chimneys and plaster, rattled nerves across towns that know their fault mostly as the thing that slowly bends their curbs. The federal pager system, which estimates impact within minutes of any significant global earthquake, issued a yellow alert, its middle tier, translating roughly as expect localized damage and possible injuries, a regional emergency rather than a catastrophe. And that is what materialized, damage assessments, some red-tagged chimneys and older structures, no widespread destruction. And Shake Alert, the West Coast early warning system this channel has covered many times, detected the rupture's first fast waves and issued alerts, giving the towns farther from the epicenter seconds of notice. Another quiet, successful live test logged for the system that will one day matter enormously more. So the main shock, in summary, was significant, sharply felt, locally damaging, and entirely within the known character of the fault it happened on. The real story of the past 18 days is what came next. But before the ledger, those 5,300 reports and that yellow alert deserve a minute of their own, because they come from two systems most viewers have never had explained, and both were working for Mendocino County within minutes of the shaking. The reports feed a program called Did You Feel It? And it is one of the great quiet successes of citizen science anywhere in the world. Launched by the Geological Survey in 1999, it is exactly what it sounds like. After any earthquake, anyone can go to the events page and answer a short questionnaire. Were you asleep? Did objects fall? Did plaster crack? Did furniture move? And the answers convert through a standardized formula into a community intensity value for your zip code or your pin on the map. Individually, one report is an anecdote. 5,000 of them, arriving within the first hours, assemble into an intensity map with a resolution no instrument network can match, because California's seismometers, dense as they are, sit miles apart, while the felt reports come from every third kitchen. And here's why it matters doubly in a region like this one. Rural Northern California is exactly where the instrument network thins out, which means in Cavallo, in Alder Springs, in the ranch country between towns, the human reports are not a supplement to the data. They often are the data, the only ground truth, available for how hard a given valley actually shook. The June 24th event drew its 5,300 reports from across the region, and the resulting map, the high sixes ringing the epicentral valleys, fading outward through the fives and fours toward the coast and the Central Valley, is as much the public's creation as the government's. When this channel asks where you were and what it felt like, it is not engagement bait, it is an invitation into the same practice. The second system is called Pager, and it answers the question every emergency manager on Earth has in the first minutes. How bad is this? Within about half an hour of any significant earthquake worldwide, Pager crosses the shaking map with a database of population, building types, and the hard lessons of past disasters, and issues an alert on a 4-color ladder. Green, little or no impact expected. Yellow, localized damage, possible injuries, an event for local and regional resources. Orange, significant damage and casualties likely, national scale response. Red, catastrophe, international response. The colors are probabilistic, published with explicit uncertainty, and they exist because in the first hour after an earthquake, especially one in a remote region, the difference between mobilizing a county and mobilizing a nation is decided before any survey team reaches the ground. Redwood Valley's yellow, issued while the aftershocks were still in their first hour, translated to expect cracked chimneys and shaken towns, not collapsed ones, and it proved accurate. The same system, on the same afternoon, would have gone red without hesitation for the identical magnitude under a city of unreinforced brick, which is the entire lesson of this series compressed into a color code. The earthquake is a number. The disaster is what the number lands on. Here's the aftershock ledger, day by day, and I am going to read it to you almost raw because the shape of these numbers is the single most reassuring thing in tonight's episode. Day 1, June 24th, 82 recorded aftershocks. Day 2, 36. Day 3, 21. Day 4, 14. Day 5, 8. Day 6, 3. And from there, a long tail, a handful of events a day. Some days 1 or 2, a modest ripple in early July, then quiet again, 211 aftershocks. In total as I record this, and remarkably, the largest of them all, just magnitude 2.6. If you watched our last episode, you already know the name for this shape. Omori decay, the century-old law of aftershocks, the rate falling by roughly half each doubling of time, and the Redwood Valley sequence has been following it almost like a demonstration built for a classroom. 82, 36, 21, 14, halving on schedule. Exactly the curve a healthy, ordinary, self-exhausting aftershock sequence draws. Even more telling is what the sequence has not produced, not a single aftershock of magnitude 3, or greater inside the main zone, when the standard statistics would have made 1 or 2 M3s entirely unsurprising. Duty seismologists watching this catalog see a main shock that spent its energy, a fault patch that broke, adjusted, and is settling, with nothing in the rate, the magnitudes, or the locations of the aftershocks themselves suggesting the zone is doing anything but going back to sleep. If the story ended there, there would be no second episode. It does not end there, because while the aftershock zone has been quieting, the corridor has been speaking. The magnitude 3.9 near Alder Springs on July 3rd, and the Kavlo pair on July 10th and 11th, the 3.8, followed 3 hours later by the 4.4, all lie outside the Redwood Valley aftershock cloud, well up the corridor to the north, on or near the same broad Macama fault system. Formally, they are separate events, each small enough to be routine on its own, each generating its own tiny aftershock forecast. And the sober reading, the one the professionals will give you, is that a fault zone this long and this active produces scattered moderate events all the time. And 3 weeks of shock stepping northward is a pattern the human eye loves and the statistics usually deflate. But it is precisely the kind of pattern that gets mapped carefully rather than dismissed because, as we said last time, a migration along a named, capable fault is filed event by event into the record that hindsight will one day grade. The honest sentence has not changed. The stepping is probably noise. It is being watched like signal. This is also the right moment to hand you one more piece of the professional vocabulary, because it decides how every cluster of earthquakes gets interpreted, including this one. Seismologists divide bursts of activity into 2 fundamentally different animals, and telling them apart is often the first question asked in any evaluation meeting. The first animal is the main shock aftershock sequence, which is what Redwood Valley is, one dominant event, clearly larger than everything around it, followed by a population of smaller events that obey the laws we have covered. decaying in time, shrinking in size, clustered on the rupture patch. Main shock aftershock sequences are, in a strange way, the reassuring kind. They have a known shape, a known ending, and a forecast that means something. The second animal is the swarm, and swarms are stranger. A swarm has no boss, no single dominant event, just a sustained crowd of comparable earthquakes, waxing and waning over days or weeks, often wandering in space, refusing the Amori curve because there is no main shock to decay from. Swarms are usually driven not by one fault patch breaking, but by something moving through the rock, pressurized fluids, magma, deep slow, slip, prying faults apart as it migrates, which is why swarms, rather than aftershock sequences, are the pattern that raises eyebrows at volcanoes, at geothermal fields, and, as our earlier episodes covered, beneath places like the Salton Sea, where swarms near the San Andreas trigger temporary official concern, and at Campi Flegrei, where the swarms are the unrest. The distinction matters right here, right now, for this corridor, because it frames the two possible readings of this summer precisely. If Alder Springs and Kovlo are simply independent small main shocks, each with its own handful of aftershocks, the corridor is doing scattered, ordinary business. If, instead, the coming weeks turn the corridor's activity into a true swarm, a sustained, migrating crowd of events without a dominant shock, that would be a different animal entirely, the signature of something moving at depth along the Macama zone, and it would move this story from the watched pile toward the studied pile very quickly. As of tonight, the classification is clear. Redwood Valley is a textbook main shock aftershock sequence in healthy decay, and the northern events are isolated small shocks, not a swarm. But now you know the two animals, and you know which one to hope for and which one to watch for, which is more than most coverage will ever teach you. And now, the centerpiece, the forecast. After the June 24th main shock, the Geological Survey's operational aftershock forecast system generated its first probabilities within the hour, and it has been recalculating ever since, absorbing every one of those 211 aftershocks and reweighting the odds as the sequence decays. Here are the actual numbers from the current forecast, the one produced this week, and we will take the windows one at a time. The one-day window. Chance of a magnitude of 3 or larger aftershock in the next 24 hours, about 1%. Chance of a magnitude 4 or larger, about 0.1%. Chance of a 5, effectively a rounding error. 18 days ago, on the afternoon of the main shock, those same one-day numbers would have been dozens of times higher. That is what Omori decay does to a forecast. Every quiet day is deflation. The one-week window. Chance of a magnitude 3 or larger, about 7.5%, roughly 1 in 13. Magnitude 4 or larger, under 1%. Magnitude 5 or larger, 1 in 1,000. The expected count of magnitude 3 aftershocks this week, most likely 0, possibly 1. The 1 month window, magnitude 3 or larger, about 24%, roughly 1 in 4, meaning it would be entirely ordinary for one more magnitude 3 to pop somewhere in the zone before mid-August, and entirely ordinary for none 2. Magnitude 4 or larger, about 3%. Magnitude 5, a third of 1%. And the 1 year window, the long tail, magnitude 3 or larger, about 72%. Aftershock sequences whisper for a long time, as our New Madrid episode took to an extreme. Magnitude 4 or larger over the year, about 12%. Magnitude 5 or larger, about 1%. And magnitude 6 or larger, 1/10 of 1%, 1 in 1,000. Sit with that last pair of numbers for a moment, because they are the ones that answer the question everyone in Mendocino County is actually asking: could this sequence still produce something bigger than the main shock? The forecast's answer is almost certainly not. 1 in 100 for another magnitude 5 class event within a year, 1 in 1,000 for a 6. Odds that shrink further with every quiet week. And to feel how far the sequence has already traveled. Compare tonight's forecast with its own first edition. In the hours after June 24th, the 1 week outlook would have offered better than even odds of magnitude 3 aftershocks, called a magnitude 4 a live possibility, and carried the standard early warning that a few percent of California main shocks are overtaken by something larger. 18 days later, the same system running the same mathematics on the same fault has marked nearly all of that down. The magnitude 3 odds cut to 1 in 13 for the week, the larger event chance reduced to a tail, and every reduction earned, not assumed, by 211 data points arriving quieter and smaller on schedule. That is what an honest forecast looks like from the inside. It is not a statement. It is a negotiation with the data, updated nightly. And this is the properly honest framing of the 1 in 24 shock statistic we discussed last episode. That statistic describes the first hours and days after a main shock, when the sequence is hot. 18 days of textbook decay later, with the largest aftershock, a mere 2.6, the window in which Redwood Valley was plausibly a foreshock, has largely closed. The sequence has voted, and it voted ordinary. Where do numbers like these come from? A brief look inside the machine, because trusting a forecast requires knowing it is not a guess. The system behind these probabilities descends from a method developed for California in the late 1980s, refined ever since, and it rests on the two empirical laws we have now covered across 2 episodes. Omori's law gives the shape of decay in time. The magnitude scaling law, 10 times more events for each unit smaller, gives the distribution of sizes. Fit those 2 laws to the actual unfolding sequence, the real 211 events, their times and magnitudes using parameters tuned to decades of California sequences, and you can integrate forward how many events of each size should the remaining sequence contain, and with what spread. The modern versions go further, treating every aftershock as capable of spawning its own aftershocks, cascades within cascades, which is why the forecast updates after every event rather than just after the main shock. What makes this operational science rather than academic exercise is the discipline around it. The forecasts are automatic, they publish within the hour, they are never quietly withdrawn when inconvenient, and they have been graded against reality across hundreds of California sequences, which is precisely how we know their calibration is honest. Sequences forecast to have a 1 in 4 chance of another. Magnitude 3 produce 1 about a quarter of the time. It is one of the very few places in natural hazards where the public gets live, tested, numerical odds, and it deserves to be more famous than it is. Now the honest pivot, because a forecast this clean can create exactly the wrong impression if I stop here. And there are 2 boundaries around those reassuring numbers that must be drawn in ink. Boundary 1, the forecast describes this sequence, not this fault. Every probability I just read applies to aftershocks of the June 24th earthquake, in its zone, over its decay. It says nothing at all, about the independent long-term hazard of the Macama fault system itself, the locked, loaded, magnitude 7 capable structure we profiled last episode, whose odds of a major rupture are set by a century and a half of accumulated strain, not by this summer's activity. The state's long-term forecasts put meaningful 30-year probabilities on a large Macama earthquake, and those numbers did not go down when the Redwood Valley sequence decayed. The sequence forecast is the weather, the fault's hazard is the climate. Do not let a calm week be mistaken for a safe fault. Boundary 2, the forecast is a map of odds, not a promise, and the low probability outcomes are low, not 0. 1 in 1,000 events happen. This channel exists partly because they happen. And the correct response to a 1 in 1,000 chance of a magnitude 6 is not fear and not dismissal. It is the same preparation that the fault's long-term hazard already demanded before June 24th, and will keep demanding after this sequence's last whisper. So let us spend 1 sober minute on that scenario in the planning register, not the panic register. A magnitude 6 class earthquake on the Yakima corridor near Ukiah or Willits, whenever the fault's own clock produces one, this year, or in 40 years, would strike towns whose historic downtowns include exactly the older masonry construction that intensity 7 and 8 shaking punishes, would test the Highway 101 corridor, the single artery those communities hang on, and would do it in a region where, as December 2022 in Rio Del demonstrated, recovery is slow, quiet, and largely self-reliant. That scenario's probability was not created by this summer's sequence and was not retired by its decay. It is the standing reality of living on the Hayward system's northern reach, and the standing to-do list is unchanged. Secure the heavy furniture and the water heater, keep water and supplies for the long rural isolation window, know your gas shutoff, keep shoes and a light, buy the bed for the events this region schedules for the small hours, and have Shake Alert on your phone because the seconds it delivered on June 24th, it will deliver again. So what, concretely, are scientists watching for from here? 4 things, and now you can watch them too. First, the decay. If the aftershock rate in the Redwood Valley zone flattens, holding steady, for weeks instead of continuing its fade, that is the sequence refusing to follow Omori, and it would earn attention. So far, it is fading on schedule. Second, the corridor. If moderate events continue stepping northward, Covello and beyond, at magnitudes 4 and above, the noise interpretation weakens with each step, and the mapped pattern hardens. So far, 2 steps, both modest. Third, the silent measurements, the creep meters and alignment arrays on the Macama we described last time, and the regional GPS, watching for any change in the fault's slow surface motion, the kind of signal that, on other faults in this series, has meant fluids or deep slip on the move. Nothing anomalous has been reported. Fourth, the forecast itself, which you can now read exactly as they do, on the event's public page, updating as the sequence breathes. If those 1-month numbers climb instead of fall on the next update, you will know what it means before the news does. That is the entire promise of this kind of coverage, not to make you afraid of a fault, but to make you fluent in one. Here's the closing thought in the quiet register. Somewhere in a data center tonight, the forecast for this sequence will recalculate itself, as it has every day for 18 days, absorbing whatever small events the evening brings, nudging its probabilities down another fraction, patient, public, and unwatched by almost everyone it protects. There's something quietly profound about that. A century ago, the people of Mendocino County would have felt the June shaking repaired the plaster, and lived the following months on rumor and nerve, every small aftershock a fresh terror with no shape around it. Tonight, a rancher outside Covelo who felt the 4.4 rattle the windows can, before going back to bed, look at the same numbers the state emergency office looks at, see the decay curve bending toward quiet, see the 1 in 1,000 for what it is, and sleep, not because the ground promised anything. The ground never promises, but because the not knowing has edges now, drawn in mathematics, updated nightly, and shared with everyone equally. That is what progress in this field actually looks like, not prediction, but the slow replacement of dread with numbers honest enough to act on. The sequence is fading, the fault remains. The watching continues, and now it includes you. If tonight's walk through a live forecast changed how you will read the next earthquake headline, tell me in the comments. I read them all. And the accounts from these counties have made this series better with every episode. Until next time, take care of yourselves and of the people on your road. The numbers keep updating in the dark, and someone is always reading them. See you soon.